Hello and welcome students. This is lecture number 18 from Indefinite Integration. In lecture number 17, we learned integration by parts. And what was that? If we have two functions, u and v, integrable functions of x, and we have to integrate the product of these two functions, we write it as u into v, then the integration of uv dx will be in u integral v dx minus big integral d by dx of u integral v dx and here dx. So now what we will do is, since we have already done this in lecture number 17 and we have also solved few problems, today we are going to solve few more problems on integration by parts. But before we do that, we will derive three very important results. If you remember, earlier I had given you three sets of theories: set 1, set 2, and set 3 theories we had already talked about. Now set 1 theory was, in set 1 theory we had integral 1 upon variable square plus constant square dx. We have already done 1 upon variable square minus constant square dx and 1 upon constant square minus variable square dx. Then in set 2 we have already derived and obtained the result when we have integral 1 over square root of x square plus a square dx and 1 over integral 1 over square root of x square minus a square dx, and x square can also be called as variable square, and square 1 over square root of constant square minus variable square dx. So difference between set 1 and set 2 is that here you have, in denominator you don't have square roots, but in set 2 the addition that you do is, in denominator you write inside the square root. Then we have set 3 theories. And what is set 3 theories? Which we are going to do today in this lecture. We are going to derive the result for the integral square root of x square plus a square dx. So you can see what is happening here. This square root, which is in the denominator of 1, it has now come in numerator. And then we will also derive the result for integral square root of x square minus a square dx, and the third one will be, yes, you guessed it correctly, it is square root of a square minus x square dx. So these three we are going to do today. And the reason for doing this set three theories today is because for deriving the result for these three theories, we need integration by parts. We are going to use integration by parts to derive the result for these three theories. So let's begin with it. So the first one I have here is, I have the first one as integral square root of x square plus a square dx. Okay, so I will start with it. So I write here, let I equals to integral square root of x square plus a square dx. Now in order to integrate this, what I will do is I will write this as integral square root of x square plus a square multiplied with 1 dx. You know, 1, if we multiply we get the same thing. Now what I do is I will take this one as u, I will take this one as u, and I'll take 1 as v. 1 I will take it as v, because I know when I apply integration by parts, it is always the second factor which is integrated. The first factor is not integrated. You can check on the RHS, you do not have u being integrated. Okay, so if I consider it this way, I will take root of x square plus a square as u. I will not have to integrate this. I will have to integrate 1 only, but at the end I will get the integration of square root of x square plus a square. So if you are thinking that are we using Liet, are we using the Liet rule here? So I will suggest you that here we are not as such. It is the common sense that we are using here. We cannot have, try to understand, if someone is thinking of taking 1 as u and square root of x square plus a square as v, like if you are deciding the order exactly the reverse way which I took. If I'm taking 1 in the as a first factor, I'm taking 1 as u, and this one if I'm taking v, then what will happen? When I will apply the integration by parts, I will get 1 integral square root of x square plus a square dx minus big integral d by dx of 1 and integral square root of x square plus a square dx and then dx for this. Okay, now you notice, since you are writing square root of x square plus a square as v, you will have to integrate that, and you should follow the common sense that we do not know integration of square root of x square plus a square. That itself was the question. That was the question that we are dealing with. Okay, we do not know integration of this. That is why we are working on it. So it is not Liet rule that we are using here. We are not using Liet rule. We are using our common sense. What is the common sense here? The common sense is we are going to take 1 as v. We will take 1 as v, so that we will have to integrate 1, and square root of x square plus a square will have to be only multiplied and once differentiated. Okay, as you know, u is never integrated directly. So here we will begin. We will write here integrating by parts. I will write here now integrating by parts. So when I write integration by parts, see, I apply it now. So I get I equals to square root of x square plus a square integral 1 dx, okay, minus big integral, and then I have d by dx of square root of x square plus a square into integral 1 dx, and then integration for this with respect to x dx. So I have I, then here I get x square plus a square multiplied integration of 1 dx is x minus, now see here, inside the bracket you have d by dx of root of x square plus a square, which is d by dx of root f of x. So you know derivative of root f of x is 1 upon 2 root f of x into d by dx of f of x. So 1 upon 2 root x square plus a square into d by dx of x square plus a square into d by dx of x square plus a square, and here integral 1 dx is x, and then close the bracket, write dx. So the next step that you get here is I equals to square root of x square plus a square into x minus big integral, inside the bracket you have 1 upon 2 root x square plus a square and d by dx of x square plus a square. It is 2x plus 0. 2x plus 0. Derivative of x square is 2x and derivative of a square is 0 into x and dx. So this 2 cancels. This 2 cancels with this 2. So we have now I equals to, I write this x first, x into square root of, this way it looks better. I write x first here. Okay, so x into square root of x square plus a square minus, here I have x into x, x square, and inside the bracket, inside the square root, I get x square plus a square in the denominator dx. Now here, how do we integrate this one? Okay, so for this, once again, we will use the techniques of transformation. We have to see this one is to be integrated. I do not have any direct result for this. So I will use transformation technique. That is, I will transform this into a form where I can apply the results which are known to me. So here I have I equals to x square root of x square plus a square minus integral. See, in denominator I have x square plus a square. So, and numerator I have x square. So what I will do is I will add a square, and since I'm adding a square, I'll have to subtract a square and dx. What I did, since in the denominator I notice I have x square plus a square, and the numerator I had only x square. So I added a square and subtracted a square. Now this way, what I'm planning to do is I shall be trying to repeat the content of the square root. What square root has inside it, I want to repeat it in the numerator. So see, in the denominator inside the square root I had x square plus a square, so I repeated it in the numerator. Now I will split the denominator. When I do that, see what I get. I will separately divide by square root of x square plus a square here. So I'll get x into square root of x square plus a square minus integral, and see here we will split this. So we get x square plus a square divided by square root of x square plus a square minus a square upon square root of x square plus a square and dx. So the next step, I get I equals to x multiplied to x square plus a square minus, now you all know students that if you have a divided by root a, it is equal to root a, because a is root a multiplied to root a, so one root a will cancel. Okay, so same way here, when I have here x square plus a square divided by root x square plus a square, so it will be I'll be left with square root of x square plus a square minus a square upon square root of x square plus a square dx. This is what I'll be left with. Now I write separate integral for these two, integral for this and integral for this. So I get therefore I equals to x multiplied to x square plus a square, then negative sign I have here, negative, and I write the integral for these two. So negative sign integral square root of x square plus a square dx, and see here you have a negative sign, here you have a negative sign, and here also is negative sign. So when you will write integral for this term, it will become positive. So you have plus integral a square upon plus integral a square upon square root of x square plus a square dx. Okay, now look at this thing, look at this thing. What is it? It is nothing but the integral which you begin with getting repeated. You begin with this, you begin with square root of x square plus a square dx, integral square root of x square plus a square dx, and it is same thing which is getting repeated here. So here what I will write, since I have started this as I, so I will write it I here. Okay, so next step I get is I equals to x into square root of x square plus a square minus I, this one is I'm writing this one as I, plus, now here I take a square being a constant outside, and I have to integrate 1 upon square root of x square plus a square and dx. Now look at this. You are already familiar to this integral. It is from set 2. It is from set 2. 1 over integral 1 over square root of variable square plus constant square, where variable is x. So we will use that. Since we already have done this result, we can directly use it. So the next step, this I will go to the left, and when I goes to left, I get here, therefore 2I equals to x multiplied to square root of x square plus a square, and here I have integral of this, which is log of mod of x plus square root x square plus a square, and I will add c dash. I'm writing c dash because this is not I, this is 2I. So the next step, I will divide throughout by 2, which will get me c dash by 2, and then finally I will write c for that. So when I divide throughout by 2 here, I write dividing throughout by 2, that is on both sides. Dividing throughout by 2. So I get here therefore 2I upon 2 as I, and here when I divide this term, I get x upon 2 square root of x square plus a square, plus here I divide, I get a square by 2, and log of mod of x plus square root of x square plus a square plus c dash by 2. Now in next step, this c dash by 2, I will write it as c. And what was I? What was I? I was the integral. So I will replace I by what it was. Integral x square plus a square dx will be equal to x upon 2 square root of x square plus a square upon 2 plus a square upon 2 log of mod of x plus square root of x square plus a square plus c, where c is equal to c dash upon 2. Okay, so this is the final result that you obtained after the derivation. So this is a very important theory. It is asked in many board exams. So I will suggest you that you see this whole video once again, you see this derivation once again, several times you see this, and you write it in your notebook. Practice it. Practicing will make you perfect. Now we take the second one. The second one is integral square root of x square minus a square dx. Okay, now what's the difference between the one that we did and in this one? It is, we did one which was square root of x square plus a square, and here we have square root of x square minus a square. We have x square minus a square. Okay, so what I suggest you is that you pause the video and you solve this on your own. You know the technique. You will start with writing this as I, and then you will write next step as square root of x square minus a square into 1 dx. You will write it into 1 dx, and then you will apply integration by parts. You will apply integration. You will write here integrating by parts. Okay, and you know when you integrate by parts, only the second factor is integrated. The first one is once multiplied as it is, and in the next step it is, next term it is differentiated and multiplied with the integral of 1 dx. So I will suggest you that you pause the video and you try solving this on your own. If you want to take help, you can once again watch the derivation of the earlier one. You can again watch this and try applying on this. Try applying on this. The best way is you watch this and then first you try doing this itself once on your own, and then you go ahead with this one. Okay, so you can pause the video and do it. Okay, I am sure you must have done it, and now let me now do it. See here, students, I will help you out for that result in this derivation itself. Now how do I do it? See, what I do is wherever I have positive sign, first of all let me make it or negative sign. Okay, So see, this is x square plus a square. This is also x square plus a square. I will make all this negative. X square plus a square is negative. Here x square plus, this is the changes that you will notice. This is the only change you will notice while writing the derivation of square root of x square minus a square. So I'm doing it for you here. Okay, so see, what do I get? What do I get? Till here, till here, I'll be getting this much. Okay, now let me, right, so here it is x square minus a square. This is integral. I take this as I assume this to be I, and then I multiply 1 to it, square root of x square minus a square into 1 dx. Then here I have square root of x square minus a square into 1 dx minus big integral d by dx of square root of x square minus a square into 1 dx and dx. This is, I'm applying integration by parts for this. I'm applying integration by parts for this. And then see, integral 1 dx is x. This remains as it is. Here d by dx of square root of x square minus a square, which is 1 upon 2 square root of x square minus a square into d by dx of x square minus a square into x. This is negative here. You will have a negative here. And see, d by dx of x square minus a square, d by dx of x square is 2x minus 0. A square derivative is 0. So you will get 2x only. You remember here when you had plus, it was 2x plus 0. So it hardly makes any difference. You still get the same thing. You get 2x and then integral 1 dx was x. So here you have x. Next step, this 2 cancels. You have here x square minus a square, and here also you have x square minus a square. Okay, now after this there will be slight corresponding changes. So what I do is, now from here I shall be now going ahead and writing everything. So from here onwards I shall be writing everything. So here the next step I write is I equals to x square root of x square minus a square minus, the denominator here I have is square root of x square minus a square. You remember in the previous result derivation you had plus here. Now you have negative. Okay. Now when you had plus, what did you do? You wrote, you have in the numerator x square, so you added a square, you subtracted a square. You remember that in the previous result, since you had plus in the denominator, you added and you subtracted. But here what is happening, in the denominator under square root you do not have plus sign. What do you have? You have a negative sign, and numerator you have x square. Now here you have negative sign. So what you will do, you will first subtract a square and then add a square. So it is minus a square plus a square, and in the earlier derivation it was plus a square minus a square. Now what we will do, we have repeated the content of the square root in the numerator. Okay, so here I have square root of x square minus a square. I have square root of x square minus a square in the denominator. That's why I tried repeating the content of the root in the numerator. Now what I'll do is I will split this denominator. So I get I equals to x multiplied to x square minus a square minus integral, and see here I will have x square minus a square divided by square root of x square minus a square plus a square divided by square root of x square minus a square and dx. So the next step you will get I equals to x multiplied to x square minus a square minus big this is integral sign, and here see what you will have, you got x square minus a square divided by square root of same So you are left with square root of x square minus a square plus a square upon square root of x square minus a square dx. So in the next step, what you do, you will write separate integral for these two. Okay. So here, see, now I make the changes. This was the first one. So let me make change here. I will, when I see here, this will be negative, and see, this is negative here, this is negative here, x square minus a square. When I will write integral of this, I'll get negative integral of x square minus a square. Now see, here I have a positive sign. I have a positive sign here. I have a negative sign here, and here I have a positive sign. So when I will write the separate integral, minus and plus, it will become negative. It will become negative. So I get here negative. So this is negative, and here I will get x square minus a square. I get here x square minus a. So this is x square minus a square, x square minus a square, and x square minus a square. This much I'll get. So here, once again, see, you are getting your integral repeated, for which you will write I. For which you will write I. So let me once again make the corresponding changes here. Okay. So this is minus, and here also this is negative, this is negative, and this also is negative. So you got a negative sign here, you got a negative sign here, and this is also negative. This a square is taken out because a square is a constant. We are integrating with respect to x. So what you get this is negative. This I goes to the left, it becomes 2i. This is negative. Okay, and we are applying the result from the set 2 theories. We are applying result from the set 2 theories. Integral 1 upon square root of x square minus a square is log of mod of x plus square root as it is. So square root as it is means it will be negative. Here we will have a negative sign. So minus here, and minus here. Okay, so what will I get? The next step I will get here, this will be negative, this is negative, this is negative. Okay, we are going ahead with the corresponding changes being made. So minus here, this is minus here, and this is minus here. Next step, I write c dash. Okay, here I divided throughout by 2, so I got this. Now in next step, I will write c dash by 2 as c. So, and moreover, this is negative, this is negative, this is negative, and this one also is negative. So you found that with corresponding changes, this result is very much similar to the derivation of the previous result. So this is what you get. Integral square root of x square minus a square is c. Here you have square root of x square minus a square. So here also you get square root of x square minus a square. And then here you got minus a square by 2. Okay, you got minus of a square by 2 log of x plus square root of x square minus a square plus c. This is second theory done. With the help of first theory, we made certain changes and we did it. If you have found it writing difficult, what you can do is you can once again go through the whole derivation, read it, and try doing it once again on your own. Now I solve for you the third derivation. The third derivation is, the third one is, let I equals to, I will begin with writing that as I integral of square root of, this is the third one and the last one, a square minus x square dx. Okay, so what was the first one? The first one was square root of x square plus a square dx. which I derived for you completely. Then the second one was square root of x square minus a square dx. I could help you out for this derivation by making certain changes in this derivation. Okay, the reason was in this we have x square positive and here also x square was positive. The sign changed only for the constant. Okay, but here what you notice, it's going to be quite different because this time x square is negative. So I will do this right from scratch till the end for you, and I want you also to practice this. So here I have, always keep pen and paper ready for writing. Mathematics can be learned only by practicing. So I equals to, next step I write integral a square minus x square into 1 dx into 1 dx. Okay, yes, and now you know not to be said which one is u and which one is v. It is common sense. I will take 1 as v because this is what I will go for integrating. I cannot integrate this one. I cannot take this one as v. Okay, because I do not know integration of that. That's the question. So here I write now integrating by parts. By parts. Integrating by parts. So I get I equals to square root of a square minus x square into 1 dx minus big integral sign, and then inside the bracket I have d by dx of square root of a square minus x square multiplied with 1 dx and again dx. You can check you are integrating only 1 dx. So here I equals to, I get here a square minus x square into x, integration of 1 is x, and big integral sign d by dx of root of a square minus x square, that is d by dx of square root of f of x. It is d by dx root f of x, 1 upon 2 root f of x into derivative of f of x. It is derivative of composite function, so we'll apply chain rule. So 1 upon 2 root a square minus x square into d by dx of a square minus x square into integral 1 dx is x, and here we have dx. So next step I get I equals to x. I write x first, this way it looks better. So x multiplied to square root of a square minus x square minus 1 upon 2 square root of a square minus x square, and derivative of a square minus x square is, the derivative of a square is 0, 0 minus 2x, derivative of x square is 2x. So here you get minus 2x, and this is the major change that we have in this theory compared to the other two theories, the earlier one that we solved. If you remember at this stage in the earlier two, we got here derivative as 2x, we didn't get minus 2x, but here we are getting minus 2x, and that makes the major change here. What's next step? The next step is this 2 and this 2 cancels. You cancel these two, so then so the next step I write is, therefore I equals to x multiplied to square root of a square minus x square minus, see, it is negative of x square. What do I get? I get negative of x square, and inside the denominator, and in the denominator inside the square root, I get a square minus, I forgot to write dx here. So I get here square root of a square minus x square and dx. So what is the next step? What's the next step here? The next step is, see, I want to integrate this. I want to integrate this. Once again, I will have to use my techniques of transformation. So I notice that inside the square root, in the denominator, I have a square minus x square, and numerator I have minus of x square. You know, some students, you might get tempted to write this negative sign with this negative sign and make it a positive sign. You know, you might get tempted to take it out and write here positive sign. okay, but multiply minus and make it positive. But please don't do that. You don't have to do it. Why? Because this negative x square is good for us, because in the denominator also you notice you have negative of x square. So what do I do here? See, I will write next step as I equals to x square root of a square minus x square minus square root of, see, inside the denominator, inside the square root in the denominator, I have a square minus x square, and here I have minus x square. Okay, so what I do is I write plus a square. See here, I write plus a square, and since I'm writing plus a square, I will have to write, I'll have to, so it means I'm adding a square, so I'll have to subtract a square. Okay, and dx. So what did I do? I repeated the denominator. I repeated the content of the square root in numerator. I had a square minus x square, so I repeated it. So here I got a square minus x square. So what did I do? I repeated the content of the square root in numerator. So here I have a square minus x square. What is next step I'm going to do? In the next step, I will split the denominator. I will separately divide by the denominator. So see here, what do I get? I get therefore I equals to x square root of a square minus x square minus big integral, and here I have a square minus x square divided by square root of a square minus x square minus a square divided by square root of a square minus x square and dx. Okay, so the next step I get is I equals to x square root of a square minus x square minus, here we have a square minus x square divided by square root of a square minus a square, so we will be left with square root of a square minus x square minus a square upon square root of a square minus x square dx. In the next step, I get I equals to x multiplied to square root of a square minus x square, and I write separate integral for these two which I have inside the bracket. So I get negative integral square root of a square minus x square, minus and minus become plus, and here I have plus integral a square upon square root of a square minus x square dx. Okay, you can check what's happening here. You are getting this integral repeated, the one that you had in the beginning. It is the same integral being repeated. So here what you will write for this, you will write I for that. You will write I for that. So this one is I. Okay, so the next step I have is I equals to x into square root of a square minus x square minus I plus, I write this a square out, a square is out, and here I get 1 upon square root of a square minus x square dx. Okay, so this I goes to the left and it makes this as 2I. What will it become? It will become 2I. So I get here I equals to x into, I'm sorry, it is not I, it is 2I. I will get here I will get here 2I equals to x into square root of a square minus x square plus a square, and here this integral is from set 2 theories. If you remember, this one is from set 2 theory. This is the third theory from this is the third result from the set 2. That was 1 upon square root of a square minus x square, and what it was equal to? It was equal to sine inverse of x upon a plus c dash. I write c dash because I still have to get I, for which I'll have to divide throughout by 2, because on the left I have 2I. So the next step I write dividing throughout by 2. I write here dividing throughout by 2. So I get on the left I get I, on the right, see here, When I divide 2i by 2, I get I. When I divide this term by 2, what will I get? I will get x upon 2 multiplied to square root of a square minus x square, and then I have plus a square sine inverse of x by a. So I will get here plus a square by 2 sine inverse of x over a plus c dash by 2. Now what was I? I will write what I was. It was integral a square minus x square dx equals to I get on the right side I have x by 2 square root of a square minus x square plus a square by 2 sine inverse of x upon a plus c. What we have done is we have replaced c dash by 2 by c, and this is the final result that we obtained. This is the final result that we got. So we have done all the three results here, students. You can once again watch the derivation of this and try writing the derivation on your own. You should practice these three derivations because these are very important problems for board exam. And definitely when you remember these results, you will be able to solve many problems even in entrance exams, respective entrance exams. Now let us write all the three results at one place. Let us write all the three results at one place. So we did the first one was square root of integral square root of x square plus a square dx. The second one was square root of x square minus a square dx. We need to remember them. The result has to be learned by heart because then only we'll be able to apply them and solve problems. Square root of a square minus x square. See the first one, okay? The first one is having the variable as x. So remember students, if the variable is x, so here you will write x by 2 and then you will multiply the square root as it is. So x by 2 multiplied to square root of x square plus a square. Then you will check the sign of a square. A square is positive, so you will write plus a square by 2. What you will write? You will write plus a square by 2. Then you think this to be in the denominator of 1. You think this to be in the denominator of 1. That is, you will use set two theories here. What you will use? You will use integral of 1 upon square root x square plus a square. What is integration of 1 upon square root x square plus a square? What is integration of 1 upon square root x square plus a square? And that you will write, you will multiply with a square upon 2. So integration of 1 upon square root of x square plus a square was log of mod of x plus the square root as it is, x square plus a square plus c, and that gets you the first result. See how simple that is. Remembering this is very simple. Once again, now look at, so there are two terms. I taught you how to write the first term as well as the second term. Okay, now let's go for the second theory. The second one is square root of x square minus a square. So what is the variable here? The variable is x. So you will write the variable upon 2, that is x by 2, and then you will multiply the square root as it is, as you did here. As you did here, you will do the same here. So here you have x square minus a square. Then the sign of a square is negative, so you will write minus a square by 2, and you will integrate 1 upon this, that is from the set 2 theory. So what is integration of 1 upon square root x square minus a square? It is log of mod of x plus square root of x square minus a square plus c. You will get this. And then the third one variable is x, so you will write x by 2. Okay, you don't have to check the sign of variable, whether it is x square positive or x square negative, whether x square is positive or x square here negative. Irrespective of that, always it is x by 2, and then multiply the square root. Multiply the square root as it is, which is a square minus x square. You will check the sign of a square. Yes, when the a square was positive, you wrote plus a square by 2. When a square was negative, you wrote minus a square by 2. Here again, a square is positive. So you will write plus a square by 2. And what is the integration of 1 upon square root of a square minus x square? It is sine inverse of x upon a plus c. So you will write it that way. And see, now you have on one page, you have all the three results. You write it several times and try remembering it. I have given you the technique for remembering this. Now using this, we are going to solve some problems. You will notice that problem that we are going to solve now, we are going to use these results. These results might be of some help in the problems to come. So let us begin solving few problems. I will begin with integral x into sine inverse x. I solve the book which I am referring to. It is from exercise 3.3. It hardly matters which exercise it is, because we are more concerned with the type of problem and the concept, not the number. Whichever book you are referring, in your book you will find integration by parts. In your book, in your notes, you will have all these theories and problems. You have to follow your book. What is important is the type of problem. You will have similar type of problems even in your book. So from exercise 3.3, I'm solving first 11th one. So here I have integral. I have to evaluate integral x multiplied to sine inverse x dx. Okay. The first thing that I do is I write this as I. Now see students, I have product of two functions. What are those two functions? I notice that x is an algebraic function and sine inverse x is inverse trigonometric function. So the first thing I noticed that this order is not proper. Why? Because see, the order which we have to have is liate, L-I-A-T-E. It should be in what order? It should be I then A. Check, I is before A. I is before A. Okay, as per the liate rule. But here it is I after A. So what I will do, I will change the order. I will first change the order. So let me first change the order. So the next step, I write I equals to, I write sine inverse x as u and x I write it as v dx. Now I start integrating by parts. I write here integrating by parts. Integrating by parts, I will have therefore I equals to sine inverse x integral x dx minus big integral sine d by dx of sine inverse x into integral x dx and dx once again. So the next step I get is I equals to sine inverse of x. Integration of x is x square upon 2 minus, here I have d by dx of sine inverse x, which is 1 over square root of 1 minus x square, and integration of x is x square by 2 and dx, x square by 2 dx. So the next step I get is I equals to x square by 2 multiplied to sine inverse x, x square by 2 multiplied to sine inverse x, and this 1 by 2, see integration of x square, integration here I have inside, I have 1 by 2 which is a constant, so I write minus 1 by 2 out, and integral x square divided by square root of 1 minus x square dx square, x square upon square root of 1 minus x square. Okay. So next what I do is this negative sign. See, inside the square root, I notice I have 1 minus x square. So since I have minus of x square, what I do is this x square, I will make it negative. I want a negative sign here, for which what I do is this negative I bring in here. So this sign will become positive. I hope you understand what I'm saying. So the next step is I write here x square by 2 and sine inverse of x plus 1 by 2 and integral minus x square upon square root of 1 minus x square dx. Okay, and why am I doing it? This is actually transformation going on. In order to integrate this, I need to transform this into a form where I can apply the result. So I write here minus x square. Okay. And why do I write minus x square? Because I would like to repeat the content of the root in the numerator. So here, now inside the square root, I have 1 minus x square, and numerator I have minus x square. What I do next is I add 1, and since I'm adding 1, I will have to subtract 1. So see here, I write plus 1 and minus 1. So as such, I have not done any change. Now what I do, I will now split the denominator this way. See, I will write 1 minus x square upon the denominator and this 1 upon the denominator. Okay, so now we are going to split the denominator. How will it be split? It will be split this way. See, 1 minus x square upon this and 1 upon this. Okay, so the next step I get is therefore I equals to x square by 2 multiplied with sine inverse x plus 1 by 2 and integral. See, I have 1 minus x square divided by square root of 1 minus x square minus 1 upon square root of 1 minus x square and dx. Okay, so the next step I have I equals to x square by 2 sine inverse of x plus 1 by 2. And see here, what do you have? You have 1 minus x square divided by square root of 1 minus x square. So you are left with integral inside the square root 1 minus x square for this part, and here 1 upon square root of 1 minus x square dx. Now in the next step, I will write separate integral for these two. I will write separate integral for the two. So I get here I equals to x square by 2 multiplied with sine inverse x plus 1 by 2 and integral square root of 1 minus x square dx minus integral 1 upon square root of 1 minus x square dx. Okay, this is getting bigger, but don't worry, it is going to be easy. See here. Now what we have here, what we have to follow is, I have now inside the bracket, I have two integrals. Inside the bracket, I have two integrals. Integral square root of 1 minus x square and integrals 1 upon square root of 1 minus x square. Okay, so how do I do it? So what I do is, I write this one I take it as, I write this one as I1. This is I1. I take this as I1 and this one I take it as I2. Okay. So the next step I get is, therefore I equals to x square by 2 into sine inverse of x plus 1 by 2. Inside the bracket I have I1 minus I2. What do I have inside the bracket? Inside the bracket I have I1 minus I2, and this is equation number 1. Now I consider I1. See, what is I1? I write here, consider I1. I1 is integral, I1 is equal to integral square root of 1 minus x square dx. You know what I do? I take this 1 as 1 square. What I do? I take this 1. I can treat this 1 as 1 square because 1 square is equal to 1. And then I will apply the one that just now we derived. You remember integral a square minus x square dx, what it was? What was integral a square minus x square dx? We are going to apply it here because see, it is in the same form. It's in the form square root of constant square minus variable square. We can apply that. So I remember what it was. It was x by 2, the square root as it is, then plus a square by 2 and sine inverse of x by a plus c. This is what it was. So I'm going to apply this here. Okay, we had recently done it. So as I told you, the problems are going to use those results. So here I have x by 2 multiplied to square root as it is, that is 1 minus x square. Then here I have plus 1 square by 2 and integral 1 upon this, that is from the set 2 theories. What is integration of 1 upon square root 1 minus 1 square minus x square? That is sine inverse of x upon 1, that is sine inverse of x upon 1 plus c1, because this is I1. So I have therefore I1 equals to x upon 2 square root of 1 minus x square plus 1 by 2 sine inverse of x plus c1. This is number 2. So I have obtained what I1 is. I have evaluated the integral I1. Now it's next I will go for I2. Now I2. What is I2? I2 is 1 upon integral 1 upon square root of 1 minus x square, which is very simple. So it is 1 upon square root of 1 minus x square. So what I do is I write this as 1 square. Now this is from set 2, 1 upon square root of a square minus x square, 1 upon square root of a square minus x square dx. And what it was, student, just now we used it here. Okay, so what is it? It is sine inverse of x over a plus c. It is sine inverse of x over a plus c here. Okay, so I get it. What do I get? I get here equals to sine inverse of x upon 1 plus c2, because this one is I2, that is sine inverse of x plus c2. I write this as equation number 3. What I do next is I write using I1 and I2 in 1. I1 and I2 in 1. So see, what do I get? I get here, I write here using I1 and I2 in 1, we get what is 1? I equals to, you remember what it is? It is x square by 2 sine inverse x square by 2 sine inverse x plus 1 by 2, and inside the bracket you have I1 minus I2 plus 1 by 2 inside the bracket I1 minus I2. And what was I1? I1 was this. So you will write x by 2 square root of 1 minus x square, x by 2 square root of 1 minus x square plus 1 by 2 sine inverse x plus c1 plus 1 by 2 sine inverse x plus c1, and minus I2. So minus sine inverse x. So minus I2, so it will become minus sine inverse x minus c2. The sign will change and the bracket close. So now I get, therefore I equals to, I get x square by 2 sine inverse of x plus x by 4 square root of 1 minus x square plus 1 by 4 sine inverse x minus 1 by 2 sine inverse x plus c1 by 2 minus c2 by 2. Okay, next step I get here x square by 2 sine inverse x plus x by 4 square root of 1 minus x square plus, now see these two both terms are in sine inverse x, so plus 1 by 4 minus 1 by 2 is minus 1 by 4. So here I get negative 1 by 4 sine inverse x, and this whole thing I replace it by c. I write a simple constant c, and here write where c is equal to c1 by 2 minus c2 by 2. Okay, so I got the final answer. as this. This is my final answer. I hope you all must have understood this. Okay, you can see the whole solution once again and try repeating it on your own. In this problem, we use the theory that we had recently derived. So as I solved for you the problem by using integration by parts, x into sine inverse x, as I solved this problem for you, you all can practice this problem on your own, which is x square into cos inverse x. Once again, what you will do first is you will change the order, because as you know, inverse trigonometric function, this is I, cos inverse x is inverse trigonometric function, and x square is an algebraic function. And as per the Liet rule, L-I-A-T-E, it is I then A. So as per the Liet rule, inverse trigonometric function has a higher priority over algebraic functions. So what I will do is I will change the order, and hence I will write cos inverse x into x square dx. Okay, so you can solve this problem on your own. You will apply integration by parts, and you will have to integrate x square only. Integration of x square is x cube upon 3, and then you can complete it. In case if you are not able to complete it, I suggest you to write in the comment box. You give your comment, and what I will do is all these problems which I'm asking you to solve and you are not getting, I shall make a doubt solving video on these problems. So what you can do is you can solve this problem on your own. I take now next question as seventh from the textbook which I am solving. It is first seventh. It is first question, seventh sub question. So let's do this question now. It is, let I equals to the given integral, I assume it to be I. It is integral sec cube x dx. It is sec cube x into dx. What I do is I write this as sec x into sec square x. See, how do I integrate sec cube x? I write this as sec x into sec square x. Okay, and I'm going to use integration by parts. I'm going to use, this is a very specific problem. You will have to learn this specifically to in order to be able to solve this. So see, when I have sec cube x, I will write it as sec x into sec square x, and I will use integration by parts. Now here, when you are using integration by parts, you understand that both are trigonometric functions. Both are trigonometric functions. So how do I decide which one should be u and which is v? Because normally, in order to decide u and v, we use Liet rule. Okay, so we see there that log has the highest priority, then inverse, then algebraic, then trigonometric, and least priority is exponential function. But here what I notice that I do not have two different types of functions. I have both trigonometric functions. So how do I decide the order? Which one should I take it as u and which one I take as v? Like whether I should take sec x into sec square x, or I should take sec square x into sec x. See, for this, we will use common sense. Now, as we all know, students, the one that you write second as a second factor, it is v, and that v is only integrated. So what I understand here is, I understand that integration of sec square x, if I write sec square x as v, then I will have to integrate sec square x, which is equal to tan x plus c. And if I write sec x as v, suppose I write sec x as the second factor, then I'll have to integrate sec x, then I'll have to integrate sec x, and integration of sec x dx is log of sec x plus tan x plus c. Definitely integrating sec square x is easier, and that is why what I will do is I will take sec square x as v and sec x as u. This is how I will do it. So as I said, we are going to use the common sense for deciding the when we are following that Liet rule is not helping us, there we will use the common sense for deciding the order of the functions. So I write here sec x into sec square x. So I go ahead and I start integrating by parts. I write integrating by parts, integrating by parts. So here I have therefore I equals to sec x integration of sec square x dx, sec x integration of sec square x dx minus big integral sign, and here I have d by dx of sec x into integration of sec square x dx and dx. So the next step I get is I equals to, I get sec x and integration of sec square x is tan x, sec x tan x minus big integral d by dx of sec x. D by dx of sec x is sec x into tan x, sec x into tan x into integral sec square x dx is tan x dx. D by dx of sec x is sec x tan x and integral sec square x dx is tan x and dx. Now, so the next step I get is sec x into tan x minus big integral, and here I have sec x into tan x is tan square x dx. So now my goal is to integrate this integral sec x into tan square x dx, for which what I will do is I will use transformation technique. That is, I shall be trying to write this into a form where I can apply the result. So I have here I equals to sec x into tan x, sec x into tan x minus integral sec x, and for tan square x I will write sec square x minus 1 dx, sec square x minus 1 dx. Next step what I do, I multiply sec x inside the bracket. So I get here sec x into tan x, sec x into tan x minus big integral, and sec x into sec square x is sec cube x minus sec x and dx. The next step I will write separate integral for this and this term. So here I'll get I equals to sec x into tan x, sec x into tan x minus integral sec cube x dx plus minus and minus will become plus plus integral sec x dx. And what do you notice? You notice that integral sec cube x is nothing but your initial question. This is what you were working on, integral sec cube x dx. So what you will do for integral sec cube x dx, I shall be writing I'll be writing I there. So this one will be written as I. So the next step I have is, therefore I equals to sec x into tan x minus I plus integral sec x dx is log of sec x plus tan x plus c dash. Once I notice that I do not have any integral sign, then only I will add the constant of integration. Here, moreover, I am writing c dash because I am not getting final I. So the next step, what will happen, students? This will go to left, it will become 2i. So I have 2i equals to 2i equals to sec x into tan x, sec x into tan x plus log of mod of sec x plus tan x plus c dash. I divide throughout by 2. Dividing throughout by 2. Dividing throughout by 2, I get here I. 2i upon 2 is I equals to, here I get sec x into tan x, sec x into tan x upon 2 and here I get plus 1 upon 2 log of plus 1 upon 2 log of sec x plus tan x plus c dash upon 2. In the next step, the c dash upon 2, I shall be writing it as c, and that will be my final answer. That will be the final answer for this. I hope you all must have understood how to integrate sec cube x dx. You can see this whole solution once again and then try solving this on your own. Don't forget to write c dash by 2 as c. This is not the final answer. You will write c dash by 2 as c, and that will be your final answer. Now I give you a practice problem based on same. You will write this question, you will try doing on your own, and that is you will integrate cosec cube x dx. As I integrated sec cube x dx, you will integrate cosec cube x dx on your own. And remember, you will start with I. Writing I is very important. Remember students, writing I is very important. It is equal to I. You are assuming this as I. You can understand, if I had not written I, then what would I have done here? What would have I done here? Only because I wrote that as I, this one was replaced by I, and I could evaluate it easily. So please, whenever you begin any integral problem, you start with assuming the integral to be I. And what you will do, you will write this as cosec cube x dx. You will write it as cosec x into cosec square x dx. And then, needless to be said, it is u, and this one you will take it as v, because integration of cosec square x dx is minus cot x. Integration of cosec square x is minus cot x plus c. Integrating cosec square x is easier than integrating cosec x dx. So you will take cosec square x as v and cosec x as u, and then you will apply integrating by parts. I hope you will be able to solve this. Thank you. Enough for this lecture. The rest problems now we will solve in the next lecture. We will take some more problems on integration by parts, as this type of problems, integration by parts, is one of the very important type of problems in indefinite integration. Thank you for now.